In the last 6 weeks, the Caribbean plate has broken 3 times. Venezuela, Mexico, and now Colombia. A magnitude 7. 4 earthquake just tore through the western half of the country, and if you've been paying attention, you already knew it was coming. Let's start with the timeline, because the timeline is the whole story. 6 weeks ago, Venezuela was hit by a double earthquake. 2 massive ruptures that struck close together and left more than 6,000 people dead. It was one of the deadliest seismic events the region had seen in decades, and it happened along the southern edge of the Caribbean plate, a boundary that most people never think about until it moves. A few weeks after that, a magnitude 7.3 struck off the coast of Mexico, closer to the border with Guatemala. It caused damage, but because it was offshore, it didn't produce anything close to the devastation Venezuela saw. Still, it added another data point to a pattern that was starting to look impossible to ignore. Around the same time, a magnitude 7.2 earthquake struck near Japan, and while that event sits on a completely different plate system on the opposite side of the planet, it fed into a broader sense that global seismics activity had entered an unusually intense stretch. None of these events are directly caused by one another across such vast distances, but together they painted a picture of a planet releasing an enormous amount of accumulated tectonic energy within a very short window of time. 3 major earthquakes, all above magnitude 7, all within the same 6-week window, all clustered around the edges of the same tectonic system. And now, on the morning of August 10th, that pattern completed itself in Colombia. The earthquake struck at 7:34 in the morning, local time, just after sunrise, when streets were filling up and buildings were filling with people getting ready for the day. The epicenter was near a town called San Jose del Palmar, in the Choco region of western Colombia, roughly 150 to 250 miles west of the capital, Bogotá. According to the United States Geological Survey, the quake struck at a depth of about 107 kilometers. Colombia's own geological service measured it slightly shallower, somewhere around 96 to 103 kilometers. Either way, this was not a shallow, surface-level rupture. It occurred deep within the subducting slab, the section of oceanic plate that is being pushed and folded underneath. The South American continent is part of the ongoing collision between the Nazca Plate, the Caribbean Plate, and the South American Plate. This is one of the most geologically active junctions on Earth, and it has been for millions of years. It is the same tectonic engine that built the Andes. The type of rupture matters here. Seismologists have described the mechanism as strike-slip faulting at intermediate depth, meaning the 2 sides of the fault slid past each other horizontally, rather than one side thrusting directly up and over the other. There's some debate over the exact orientation of the fault, whether it trends northeast with a left lateral motion or northwest with a right lateral motion. But either way, the depth of the quake is what limited the surface destruction. Had this same amount of energy been released at a shallow depth directly beneath a major population center, the death toll and destruction would likely have been far worse. Instead, the energy had to travel more than 100 kilometers before it reached the surface, spreading out and losing intensity along the way. That distance almost certainly saved lives, but it also meant the shaking was felt across an enormous area rather than being concentrated in one location. And felt it was. Reports of strong to severe shaking came in from across western Colombia, hitting cities like Cali, Pereira, Manizales, and Quibdó almost simultaneously. Even Bogotá, sitting well inland and at high elevation, felt the shaking strongly enough that people evacuated office buildings and apartment complexes, even though the city avoided the kind of structural damage seen further west. The mayor of Bogotá later confirmed some buildings had cracked, but there were no reports of severe collapse in the capital. Farther out, the shaking reached across international borders, felt clearly in Panama to the north and in Ecuador to the south, a reminder of just how far energy from a deep, powerful rupture like this one can travel. For a country that experiences frequent seismic activity, this was something else entirely. Colombia's Geological Service called it the strongest earthquake to hit the country in the last decade. Now let's talk about what that earthquake actually did on the ground, because the numbers here have been climbing hour by hour since it happened. In the first hours after the quake, early reports put the death toll in the dozens. By the time international outlets began publishing fuller coverage, that number had already crossed 100. As search and rescue operations continue, the most recent figures put the death toll above 130 people, with over 500 injured, according to Colombia's Association of Capital Cities. These numbers are almost certainly not final. In disasters like this, especially ones involving building collapses in dense urban centers, the death toll tends to rise for days, sometimes weeks, as rescue teams work through the rubble and hospitals report on patients who don't survive their injuries. The city of Cali, home to roughly 2 million people, was among the hardest hit. Local officials reported around 30 collapsed structures within the city alone. Among those structures were sections of a hospital, including its pediatric and neonatal units, which had to be evacuated in the middle of the emergency. Picture that for a moment. A hospital, the place people run to when disaster strikes, itself becoming a casualty of the disaster, forcing staff to move newborns and sick children out into the chaos rather than treat them inside. Rescue teams and ordinary residents worked side by side, picking through the wreckage, searching for survivors trapped beneath collapsed concrete. In Manizales, one of the region's historic cathedrals sustained visible damage, its facade cracked and partially crumbling, a striking image of just how widespread the destruction was, reaching even into structures that had stood for well over a century. More than 20 municipalities across western Colombia were affected in some way, whether through building collapse, infrastructure damage, or disrupted utilities. Roads cracked, water systems were knocked offline in some areas. Airports across the region suspended operations, first 6 of them, then 7, as authorities inspected runways and terminals for structural damage before allowing flights to resume. That's not a small disruption. And when you shut down that many airports simultaneously, you're not just grounding planes, you're cutting off some of the fastest routes for aid, personnel, and medical evacuation to reach the hardest hit communities. In the hours after the quake, at least 21 aftershocks were recorded, a mix of smaller tremors that, while nowhere near the strength of the main shock, were more than enough to send already damaged buildings the rest of the way down, and more than enough to keep an already terrified population on edge. The government's response moved quickly. Colombia's newly inaugurated president, who had only been sworn into office days before this earthquake struck, announced that he was personally taking charge of the emergency response, traveling to Bogotá to coordinate relief efforts directly. He addressed the country publicly, telling Colombians going through this crisis that they were not alone. The national government declared a state of disaster and deployed soldiers to assist with search and rescue, security, and the distribution of aid in the affected zones. The United States State Department also confirmed it was actively assisting American citizens caught up in the disaster, a detail that matters more than people realize, because Colombia receives hundreds of thousands of American tourists every year, making Americans one of the largest groups of foreign visitors in the country at any given time. There's also a secondary hazard that's been developing alongside the earthquake itself, and that's volcanic activity. Shortly after the main shock, a volcano in the region showed a sudden increase in eruptive behavior, sending up a visible plume of ash and gas. This isn't a coincidence, and it isn't unprecedented. There is a well-documented relationship between large earthquakes and nearby volcanic systems. When a massive amount of seismic energy passes through the crust, it can physically disturb magma chambers, changing pressure conditions in ways that either trigger new eruptive activity or accelerate eruptions that were already building. This has happened before in this exact region, and it's part of why volcanologists and geologists will be watching this particular volcano closely over the coming days and weeks, because a deep earthquake followed by increased surface eruptive activity is a pattern that has shown up again and again throughout geologic history on multiple continents, going back over a century of recorded observations. Colombia is home to several active volcanic systems strung along the same subduction margin that produced this earthquake, and authorities have already begun monitoring air quality and ash dispersal near the affected volcano, since ashfall can ground flights, damage aircraft engines, and create respiratory hazards for communities downwind. In some past cases, this kind of post-earthquake volcanic unrest has settled back down within days without escalating into a major eruption. In other cases, it has taken weeks for the full response to play out, sometimes building toward a larger eruptive event well after the initial earthquake has faded from headlines. That delayed timeline is one of the reasons scientists are cautious about declaring the danger over just because the immediate shaking has stopped. So now we get to the bigger question, the one that's been circulating heavily online since this earthquake struck. Could this have been predicted? And more pointedly, were people already warning about this before it happened? Here's where we need to be precise, because this is a subject that gets distorted very easily in both directions. The official position from the United States Geological Survey, and from essentially every major seismological institution on Earth, is that earthquakes cannot be predicted with precision. Not the exact date, not the exact location, not the exact magnitude. And that's not an opinion, that's the honest state of the science. Despite decades of research, no method has been developed that can reliably tell you an earthquake of a specific size will strike a specific fault on a specific day. Anyone claiming they can do that with consistent accuracy is not working from an established scientific method. But here's the part that often gets lost in that conversation. Prediction and forecasting are two very different things, and forecasting is real, it's rigorous, and it's used by seismologists every single day. Forecasting doesn't tell you an earthquake will happen next Tuesday at 9 in the morning. What it does is assess probability over a longer window, sometimes years, sometimes decades, based on the physical behavior of fault systems. Seismologists study something called recurrence intervals, which is essentially the historical rhythm of how often a particular fault has ruptured in the past. If a fault has produced a major earthquake roughly every 50 to 80 years for the last several centuries, and it's now been 85 years since the last one, that fault gets flagged as having elevated risk. That's not a guess, that's math, built on physical evidence, seismic records, and in some cases, geological trenching that reveals the fault's rupture history going back hundreds or even thousands of years. There's also a well-established concept in seismology called stress transfer, sometimes referred to through models like Coulomb stress change. When one section of a fault ruptures, it doesn't just release energy locally, it redistributes stress across the surrounding crust. Some nearby fault segments get pushed closer to failure. Others actually get relieved of stress and pushed farther from rupture. This is measurable, published, peer-reviewed science, and it's exactly why seismologists pay close attention when multiple large earthquakes occur in the same general region within a short window of time. It doesn't mean the next one is guaranteed. It means the probability shifts, sometimes meaningfully, for the surrounding fault network. Scientists have documented this kind of triggered activity on faults separated by hundreds of kilometers, and in rare, well-studied cases, on faults separated by continental distances, where a major rupture appears to have nudged an already stressed, already near-critical fault system a little closer to failure. The key word there is already. Stress transfer doesn't create risk out of nothing. It acts on faults that were already accumulating strain over decades or centuries, effectively speeding up a clock that was already ticking, rather than starting a new one from zero. That distinction matters because it explains why these clustered sequences of major earthquakes tend to happen in regions with long, well-documented histories of seismic activity, rather than appearing randomly in places with no prior earthquake record at all. This is likely what was behind the warnings that circulated after the Venezuela earthquakes back in June. Independent researchers and online seismology commentators pointed to the historical pattern between Venezuela and Colombia, noting that in past decades, major earthquakes in one country had, on more than one occasion, been followed by significant activity in the other within a window of several months. They weren't claiming to know the exact date or magnitude. They were pointing at elevated regional risk based on historical recurrence and the physical reality of stress transfer along a connected plate boundary. 6 weeks later, a magnitude 7.4 struck Colombia. Does that prove the method works with precision? No. Does it show that paying attention to regional seismic patterns has real value, even without pinpoint prediction? That's a much more reasonable conclusion, and it's one that doesn't require believing in anything outside of mainstream geology. Where things get shakier and where a healthy amount of skepticism is genuinely warranted is when broader claims start getting attached to this kind of forecasting. Claims involving solar activity, geomagnetic storms, lunar alignment with plate boundaries, or dramatic language about pole shifts and magnetic reversals. And some of these ideas touch on real, ongoing areas of research. There is legitimate scientific interest in whether space weather and geomagnetic activity can act as a minor triggering mechanism for seismic events that are already primed to rupture. But legitimate scientific interest is very different from a confirmed, validated predictive tool. Right now, the honest answer from mainstream geophysics is that any connection between solar storms and earthquake timing remains unproven, statistically weak at best, and nowhere near strong enough to be used as a forecasting method on its own. The same goes for claims about pole shifts driving current seismic activity. Earth's magnetic poles do move, they always have, and the rate of that movement has increased somewhat in recent decades. But that is fundamentally different from an actual magnetic reversal or excursion, which would require specific, measurable characteristics we simply are not seeing right now. Magnetic field strength remains within normal historical ranges. The poles remain in geologically ordinary locations. Stretching that into a narrative about an imminent pole shift driving this earthquake activity isn't supported by the data. So where does that leave the idea that officials are lying about earthquake prediction? The more accurate framing isn't that there's a hidden working prediction system being suppressed. It's that there's a real, useful, and probabilistic forecasting science that doesn't always get communicated clearly to the public, sitting right next to a lot of speculative, unproven ideas that get mixed in with it online, sometimes intentionally, sometimes just out of genuine enthusiasm from people trying to make sense of terrifying events. When a major earthquake strikes, human beings want explanations, and they want them immediately. That desire creates fertile ground for narratives that promise more certainty than the science can actually deliver. The truth sits in between the two extremes. It's not nothing, and it's not everything. Now let's talk about what comes next, because that's the question on everyone's mind in the region right now. Aftershock activity is the most immediate concern. After a main shock of this size, a magnitude 6 aftershock is considered a realistic possibility in the days and weeks that follow, and given how many buildings across Choco, Valle del Cauca, and Caldas have already sustained structural damage. Even a moderate aftershock could bring down structures that are currently standing on damaged foundations. This is one of the most dangerous phases of any major earthquake sequence because the initial adrenaline and emergency response has often started to fade. People begin returning to homes and workplaces that look intact from the outside. And then a secondary shock arrives and finds a population that's let its guard down just slightly too soon. Beyond the immediate aftershock risk, there's the broader regional question. Colombia sits within a chain of interconnected seismic zones that stretch from Venezuela through Colombia into Central America and up toward Mexico and the southwestern United States. This entire margin is part of the wider system of subduction and transform boundaries that ring the Pacific, commonly referred to as the Ring of Fire. Over the past year, that ring has been unusually active, not just in the Americas, but across the Pacific as well, with elevated earthquake activity reported in Japan, the Philippines, Indonesia, and several other Pacific nations. Whether that broader pattern of activity is connected through some larger mechanism, or whether it's simply the normal, sometimes clustered randomness of a planet that produces tens of thousands of earthquakes every year, is a genuinely open question among researchers. And reasonable scientists disagree on how much weight to give to global clustering versus regional, localized stress transfer. What we can say with more confidence is that historically, this specific corridor, from Venezuela down through Colombia and Ecuador, has shown patterns of reciprocal activity, where a major rupture in one country has, in multiple documented instances across the last century, been followed by significant seismic activity in a neighboring country within a window ranging from days to roughly a year. That doesn't guarantee anything is coming next. It does mean that emergency planners, geologists, and residents across the broader region have real evidence-based reasons to remain alert, rather than assuming that because Colombia has now had its major event, the pressure has been fully released across the entire system. For the people actually living through this, the science matters less than the immediate reality. Families are searching for missing relatives. Rescue crews are working through collapsed buildings with search dogs and heavy equipment, racing against time to reach anyone who might still be alive beneath the rubble. Hospitals that are still standing are operating well beyond capacity, treating a flood of injuries from collapsed structures, falling debris, and the chaos of tens of thousands of people trying to evacuate buildings simultaneously. Emergency shelters are being set up in open spaces, schools, and community centers for the thousands of people whose homes are no longer safe to enter, even if they didn't fully collapse. And all of this is happening while the ground continues to shake intermittently, as aftershocks ripple through an already traumatized population. Videos coming out of the affected cities in the hours after the quake show the human side of this in a way statistics never fully can. People running out of shopping centers and office buildings as ceiling tiles and light fixtures rain down around them, a church tower cracking and shedding stone in the middle of a service. Families standing in the street clutching whatever they managed to grab on their way out, watching the buildings they'd lived in for years shudder and, in some cases, come down entirely. In one widely shared clip, a man inside an airport terminal can be seen recording as the shaking builds from a faint tremor into something violent enough that he has to drop to the floor and take cover under a table, the kind of footage that captures just how quickly a normal morning can turn into a life-threatening emergency with almost no warning at all. These are not abstract data points. They are the lived experience of a country processing a disaster in real time, and they're a reminder of why the science behind these events matters, not as an academic exercise, but because a few extra seconds or minutes of warning or a slightly more prepared population can change outcomes for thousands of people. This is also a moment where international aid becomes critical. Organizations that specialize in rapid disaster response, providing meals, medical care, and emergency shelter, typically begin mobilizing within the first day or two after an event of this scale, coordinating with local government agencies to reach the communities that need help most urgently. Given Colombia's geography, with much of the worst-hit area concentrated in Chaco, one of the country's less developed and more remote regions, getting aid and equipment into some of these communities is likely to be a significant logistical challenge over the coming days, even as the broader emergency response ramps up around the country's major cities. Roads through this part of the country wind through dense terrain and mountainous passes, and even under normal conditions, travel between smaller towns and the larger cities can take hours, with roads cracked, bridges potentially compromised, and landslides a real possibility in the steeper, more forested sections of Chaco. Following this much shaking, some communities may end up cut off from ground transport entirely, forcing aid organizations to rely on helicopters or small aircraft to reach them, at least in the first critical days of the response. This is often where the difference between a well-coordinated disaster response and a chaotic one becomes most visible, in how quickly authorities can identify which communities are cut off, get accurate information out of them, and route resources accordingly, rather than concentrating all available aid in the places that are easiest to reach simply because they're the most visible. Stepping back from the immediate crisis, there's a larger lesson here that applies well beyond Colombia, and it's worth sitting with for a moment. This region, along with much of the Pacific coast of the Americas, the Caribbean, and large stretches of Asia, exists within earthquake country. That's simply a geological fact, not a matter of opinion or prediction. If you live in one of these zones, the question was never really if a major earthquake would eventually strike near you, it was always when. That's true whether you're in Western Colombia, coastal Mexico, Japan, Indonesia, or California. Earthquake preparedness isn't about living in constant fear of the ground opening up beneath you. It's about having a plan in place before you ever need it, so that when the shaking starts, you're not making critical decisions in the middle of chaos and adrenaline. Knowing where you'll take shelter in your home or workplace, having basic emergency supplies like water, food, and a first aid kit ready to go, and knowing evacuation routes for the buildings you spend the most time in. These are simple steps that consistently make the difference between life and death when the ground actually does move. It's also worth thinking about the buildings themselves, not just your own behavior inside them. Much of the destruction seen in disasters like this one comes down to construction standards, how a structure was built, what materials were used, and whether local building codes actually account for seismic activity in the first place. Older buildings, informal construction, and structures built before modern seismic codes were widely adopted tend to be the ones that come down first, while newer, properly reinforced buildings in the same neighborhood can often be left standing with only cosmetic damage. That's part of why earthquakes with similar magnitudes can produce wildly different outcomes depending on where they strike. A magnitude 7.4 in a region with strict building codes and well-enforced construction standards can result in a relatively low death toll, while the same magnitude in a region with older infrastructure and inconsistent enforcement can be catastrophic. This isn't a criticism aimed at any single country, it's simply the reality of how seismic engineering interacts with economic development. And it's one of the reasons international engineers and geologists study events like this one so closely, looking for lessons that can be applied to building codes and emergency planning in other vulnerable regions around the world. As search and rescue operations continue across Western Colombia, and as the death toll continues to be updated in the coming days, this earthquake will almost certainly be studied for years by seismologists trying to better understand the relationship between these clustered events across the Caribbean and South American plate boundaries. Was this the natural, expected continuation of stress transfer following the Venezuela and Mexico earthquakes? Exactly the kind of pattern that regional forecasting models would predict, even without pinpointing the exact date. Or is there something more happening within this broader system that current models aren't fully capturing yet? Right now, in the immediate aftermath, those are still open questions, and honest scientists will tell you they don't have complete answers yet, even as new data from seismic stations across the region continues to arrive and reshape the picture hour by hour. What isn't an open question is the human cost sitting in front of us right now. Families across Cali, Manizales, Pereira, and Quibdó are grieving loved ones, searching through rubble and trying to figure out where they'll sleep tonight. That reality deserves attention just as much as the geology behind it, if not more. As this story continues to develop, the death toll, the scope of the damage, and the response from both the Colombian government and the international community will keep evolving, and it's worth staying informed through verified sources as the full picture comes into focus in the days ahead. For now, the images coming out of Cali, Manizales, Pereira, and Quibdó tell the story more clearly than any statistic can. Streets filled with concrete and twisted rebar where apartment buildings used to stand. Rescue workers calling out into the rubble, pausing, listening for any sound of a response. Families waiting outside collapsed structures, some clinging to hope, others already grieving. This is what a magnitude 7.4 earthquake looks like up close, stripped of the graphs, the depth measurements, and the fault mechanics. Behind every number in this story is a person, a home, a business, a community that existed yesterday morning in a completely different shape than it exists today. Whatever conclusions researchers eventually draw about the seismic pattern connecting Venezuela, Mexico, and Colombia, the immediate priority remains the same as it always is after a disaster like this: finding survivors, treating the injured, and helping a shaken country begin the long process of rebuilding.